Hi everyone, this video is about the so-called real rule for significant figures, and I think we can demonstrate that using this problem. This problem really is just a dilution problem where we have some stock solution that we've diluted from 5 mils to 100 mils. That would be the dilution factor. So the final concentration of our solution then would be 5.10 milliliters cancel. So that would be parts per million. And then we're going to have to propagate some air. So we'll do that in a minute. But why does my answer have 3 sig figs? Well, that's because I just followed the rules for significant figures as usual. So I got 3 sig figs based on the rules that we've been taught since general chemistry. But let's go ahead and propagate some error. We're going to have to follow the rules for multiplication and division, which means that we're going to have to convert all of these absolute errors into percent relatives. So the percent relative error of our result will be the square root of 5 over 102 times 100, the quantity squared, plus 0.02 over 5.00 times 100, the quantity squared, plus 0.06 over 100.00 times 100, the quantity squared. And when I did the arithmetic, I got 4.92, and that 9 and 2 are insignificant percent. So can we convert this percent relative error into absolute? So again, what is 4.92% of this concentration? So 4.92% of 5.10 ppm, when I did the arithmetic, I got 0.2 with an insignificant 509, which suggests that I have a concentration of 5.10 plus or minus 0.3 ppm, and now I'm a little bit concerned. I'm a little bit concerned because my uncertainty has 1 decimal place, but yet my concentration has 2 decimal places. That doesn't seem right. In other words, how can we know the result? How can we know the result with more precision than we know the uncertainty? Something isn't quite right. That's kind of like saying that the average cost of a textbook is $155.55 plus or minus $5. If you only know the uncertainty to the nearest $5, you would never include the 55 cents. So that takes us to the real rule for sig figs, which is right here. The first non-zero digit of the absolute error is the last sig fig in the answer. So when we got that erroneous or absurd result of 5.10 plus or minus 0.3 ppm, we really need to use the real rule, which would tell us that the first non-zero digit in the absolute error is the last sig fig in the answer. So this should be reported simply as 5.1 plus or minus 0.3 ppm. So that is the real rule for sig figs. Here it is stated, but it's really a consequence of the measuring devices that we use. So hope you enjoyed this video, and thanks for listening.